Alright guys, so for your 10.7 lesson, we're going to talk about angles that are formed by secants and tangents. So basically the concept here is you're going to be looking at your angle, your intersection, and saying, is that point in, on, or outside the circle? That's what's going to happen in this lesson. The first one's going to be your tangent and intersected chord theorem. This is going to let you know that if you have a tangent and a chord and they intersect at a point, this is where you're going to see that on the circle, then the measure of each angle formed is half the measure of the arc. So to clear this up a little bit, we'll go ahead and write in a formula here. Basically what this is saying is that your angle is going to be equal to half the arc. Well, we like to put, instead of saying half times something, we like to divide by 2, so we can just say our arc over 2. Now you may have to go the other direction and find the arc. So we just switch that around and say, okay, well your arc is going to be equal to 2 times the angle measurement. Okay, so those are two little slight formulas you can look at to help you out with this. So the first problem that we have here, we're given the angle measurement, we're looking for the arc. So this is where we're going to have to kind of go back, work a little bit backwards. We can also use this formula right here if you'd like to. So there's 2 different ways you can look at this. You can say, okay, if we have our angle measurement of 30, we can set it equal to, well, our arc is x, we don't know, over 2. So then we know to set this up as proportion. When we do our cross products, we're going to get x is equal to 60. The other way is to follow the other formula, okay, which you're not going to have written down on your cheat sheet or anything, but if you can remember just the opposite, we've got our arc length is going to be equal to 2 times, well, what was our angle measurement right here? 30. So then this will be same thing, 60 degrees. So you have 2 different ways that you can work that out when you need to work backwards. Okay. The next example has some algebra with it. So the easiest way we're going to do this is working backwards with our proportions. So when we take a look, we see that our angle measurement right here of 89, so that's going to go on the left-hand side, is equal to the arc divided by 2. So the arc is 11x plus 2 all over 2. Set up our proportion. When we do our cross product, we only have 1 times 11x plus 2, so simply just 11x plus 2 will all be equal to 89 times 2, which is going to give us 178. So we just go through our steps of solving for our variable. We should be really, really good at by now. After our subtraction and our division, we're going to find out that x is equal to 16. Now remember, we do have algebra up there, so you always need to go back up and look, what do they want us to find? Are we substituting back in? This, they just wanted x, so we're safe. So this is your process of if your intersection is going to be on the circle. The next theorem we talk about is your angles inside the circle theorem. Wow, what a name, right? So we've got angles inside a circle. This is going to deal with 2 chords. So if we have 2 chords that intersect inside a circle, so now we're going inside the circle, then the measure of each angle, okay, so we're looking at the angles here, the measure of each angle is 1/2 the sum of the arcs, okay? We also need to realize that these 2 angles inside are going to be vertical angles. So that's automatically going to tell you that both of these angles are going to be congruent. So the easy way to look at this formula here is 1/2 the sum of the measure of the arcs. Well, let's take a look. Your angle is going to equal half the sum. Well, let's take the sum of the arcs. We'll say A1 plus A2 all over 2. Okay, so we can use that formula kind of like when we were dealing with our quadrilaterals and we did base 1 plus base 2 over 2. Same thing with area of triangle, base times height over 2. All right, same thing as taking half. So we take a look at our first example here. Again, all we're looking for is finding the value of x. So when we're looking for x, we're looking for the angle measurement. So we don't know our angle, so it's just going to be x. And this will be equal to, well, we want it, doesn't matter since we're adding, it does not matter which one is arc 1 and arc 2. So we just do our 70 plus our 30 all over 2. So this will end up being 100 over 2, giving us x equals 50. Not too bad, right? Just have to remember in, on, or outside. Okay. Next question, going to stay with the angles in a circle theorem. And we will take a look here. We are now going to have to work backwards on this one because of the fact that we have the angle, we don't have one of the arcs. So not a big deal. We know that our angle measurement will follow that formula of arc 1 plus arc 2 divided by 2. But this time we have our angle, 80 degrees. This will be equal to, well, we have the x plus 110 all over 2. Since we have this over 2, set up our proportions. Cross product, we're going to wind up with x plus 110 is equal to, well, 80 times 2. It's going to give you 160. Follow through with our math. We only have one step to take to solve, and x is going to come out to equal 50. So that's what happens if you're missing an arc. Now let's take a look at number 5. It's going to change up a little bit. The first thing we need to do is we need to find x. Well, in find x, we know that x is just going to be, here, is going to be this arc, okay? We're going to have to use this arc as well, the 135. The problem is that we need an angle. Well, we can get that, we can find its angle, remembering that we have vertical angles. Also knowing right here, we have a linear pair, okay? So to solve for x, we need to remember our linear pair so we can find our angle measurement. So we take that 180, subtract the 40 degrees, and we're going to find out that this other angle is 140. So we're going to use that 140, and we're going to do the exact same process we just did for example 4. Because we're given the angle, we're looking for an arc. So switch colors to make this a little bit easier for you guys to see. Continuing on, we have our angle measurement, 140. We're going to set that equal to x plus 135 all over 2, and then do our cross products, cross multiply, and solve. So we just wind up with x plus 135 is equal to 140 times 2 will give us 280. Okay, solve for x. We only have that one step to take. Subtract that 135, and then x will come out to 145 degrees. Okay, so there's your x. Now to solve for y is going to be a little bit easier because now that we have all three, you can use the exact same process as what we just did, and you can do your angle is equal to y plus 50 over 2. Or, guys, look, all we're looking for is the remainder part of this arc. And we've done this many times. Add up what we've got here. So for y, all we need to do is take, okay, we've got our x, 145, plus the 50 degrees over here, plus the 135 over here, plus y. We know that the whole circle adds up to 360 degrees. So we combine our like terms right here. We're going to wind up with 330 plus y equals 360. Last step, we're going to do our subtraction. Y comes out to 30 degrees. So we've got an easier way of solving that one. All right. The last theorem we're going to talk about is now what happens if that angle is outside of the triangle. Hence, angles outside the circle theorem. Sorry, it's a triangle. So again, we got that goofy name, just saying angles outside the circle theorem. Well, it's exactly what's happening is you're seeing that this angle is now outside. So if we have a tangent and a secant, we could have two tangents, we could have two secants, any of these, okay? If they're going to intersect outside, there's a reason I'm highlighting the in, outside, and on in different color. If we are outside, then the measure of the angle is 1/2 the positive difference between the two arcs. The positive difference just means subtract the smaller number from the larger number. That way you don't get a negative number. So here we can look at our formula being the measurement of your angle is equal to A1 minus A2. So now we're subtracting, and we'll put that all over 2. So when it's outside, we're going to subtract. So we'll go ahead and do our same example here, or we'll do our next example. Taking a look here at, we're just finding the value of x. We don't even have any algebraic expressions to plug into. Well, here I have one of my arcs. I need my other arc. Well, that's simple here. We know that the whole circle is 360 degrees. So we just take that 150 on the first arc on the right, subtract it from that 360. We're going to find out that your major arc is going to be 210 degrees. So we're going to need these two numbers to help us out. So our angle measurement of x right here is simply going to be, now this is where you want to put the bigger number first, 210 minus the 150, so that we get a positive number all over 2. 210 minus 150 is going to give you 60 over 2, letting us know that x is going to equal 30 degrees. So that's going to be that measurement. All right, so this time we're just doing our subtraction. 2 more problems, guys. Almost there. Next, we're going to have a secant. It's going to slice through that circle, and we have a tangent that barely touches that circle. So here's these intersections, keeping in mind that our angle is outside, telling us that we're going to be doing subtraction. So we're going to want to take our formula. Angle measurement is arc 1 minus arc 2 all over 2. But this time we're going to work backwards because we have the angle measurement of 40. So we have 40 equals, well, here on x, I want you guys to notice, arc x is going to be smaller than the 150 degrees. So you know which order to put everything in here, okay? We can see that it's going to be a little bit smaller. So we need the bigger number first, the 150 minus your x, all over 2. And let's solve our proportions here. So we're going to wind up with 150 minus x is equal to 40 times 2 is 80. Here we're going to subtract the 150 from both sides, remembering we have that minus x that now becomes a negative x. It's okay. Our 80 minus 150 is going to give us a negative also, but we've seen this before. And it's perfectly fine because then we have this invisible negative 1 in front of the x, so we divide both sides by that negative 1, and now we have a positive. So the smaller arc here is going to be 70 degrees. Now we'll take a look at our algebra here. We've got some algebraic expressions to throw in. We need to see two different arcs. Okay, we have that line there to help us. We have the 50. Okay, we have another tangent and secant intersecting, and then our other arc is going to be over here, that 4x plus 5. The 4x plus 5 will end up being the larger arc. So when we set that up, we want to remember that. Here we're only solving for x, which we don't have a number. It's just algebra everywhere, isn't it? So let's take a look. We're setting up our angle, x plus 25. This will be equal to the 4x plus 5 minus this 50. We are outside, so we are still subtracting, all over 2. Well, I'm going to go ahead and take care of this plus 5 minus 50 right here. This is all going to turn out to be 4x minus 45. Okay, I'm going to go ahead and combine those like terms there. So we set the x over 20 plus 25 over 1. We do our cross product here. We're going to wind up with just 4x minus 45 now. Will be equal to, we're going to have to do some distribution. Remember that whole number is outside. The algebraic expression goes inside, x plus 25. So we'll go through. Let's do our distribution here. We have 4x minus 45. Make sure I'm still on the screen. Is equal to 2 times x is 2x. And then 2 times your positive 25 gives you a positive 50. So now we just need to move our variables to one side, constants to the other, and complete the solving. So I'm going to move my smaller variable with the smaller coefficient. So I'm going to wind up with 2x minus 45 is equal to 50. Get the constant to the other side. So we've been doing all year. We've been doing for years, actually. We wind up with 2x equals 95. So we do have an odd number divided by 2, so we know we're going to have a decimal. I'm falling off the screen again. So we're going to wind up with x is equal to 47.5. So again, all this is dealing with is looking at the angle. Is the angle on the circle? Is it inside the circle? Or is it outside the circle? And that's where you need to go look up which formula you need to use for that. And that'll be it.